Okay, so let me quickly tell you the answer. The value of friction at this end, at this contact, the direction would be opposite to the applied external force, and the value will be the maximum possible value. It will be 60 Newton. Okay, and at this point it will be again opposite to the applied force, but this time the value will be 80 Newton. Let's see why and how. First of all, since the applied force is greater than the limiting friction, the value at least at one end, the whole of the friction should act at least at one end. Because if that is not the case, if the whole limiting friction is not acting at least at one end, then what would happen? The block will start to move. At least one of them will start to move. If you have applied 120 Newton and if this is not completely 90 Newton, it will have a tendency to move. Similarly, if it is 100 Newton, the external force is 100 Newton, and if you're not applying completely 60 Newton, then this block will have a tendency to move. At least one of them will start to move. That's why they, at least at one end, total limiting friction should act. And if total limiting friction is acting, then what could happen is the other block will not move, even if the entire limiting friction is not acting on it, because the tension would be generated to balance the force, such that even if the limiting friction is not acting, the block is not moving. Let's see. Suppose at this point the entire limiting friction is acting. Obviously the direction will be opposite to the externally applied force. Now let us assume that on 10 kg block, externally you are applying 120 Newton and the friction force is 90 Newton, the complete maximum value, 90 Newton. Now the force left out, in order so the system remains, the block remains stationary, would be 30 Newton. That means that 30 Newton is going to come from tension. Tension is always acts away from the body, we know. So this 30 and 90 adds up to 120. So the condition of equilibrium is satisfied. Now if tension at this end is 30 Newton, then the tension at the other end will also be 30 Newton. 30. Now the maximum force possible here is 60 Newton. Even if the maximum force is acting, that adds up only to 90. That is still short of 10 Newton. So this block by no way can remain stationary. So the case that we have considered will not be actually the case. So now let's consider the other way around. Suppose at this end the maximum limiting friction is acting. Okay, then 60 Newton is acting leftward, 100 Newton is acting rightward. The difference is 40. That should come from tension. Suppose the tension developed is 40 Newton. Fair enough, this will remain stationary. Now at the other end, the value of tension will remain the same, 40 Newton. Leftward force is 120 Newton. The difference is 80 Newton, and 80 Newton is possible because the maximum limiting friction is 90. So in this case, we have a condition in which both can remain stationary. So this is how you're going to work this kind of problem. Consider case by case, one by one, and then see which one is feasible. Now, we had this discussion before, and just to remind you in case you have missed it from your memory, friction force, the value that we write, F limiting, that is equal to mu times N. But this is a maximum force that can be applied. Suppose the value of FL is 30 Newton. Then if you apply 10 Newton on the block, then the block is not going to move. The block is not going to move because the applied force is 10 Newton and the resistive force, which is friction, will also be 10 Newton. Even though the mu times N will come out as 30 Newton, but when the external force is 10 Newton, then the friction force is less than the limiting force. Friction force is self-adjusting. It adjusts its value equal to the external value if the external force is less than the limiting friction. So if you keep on increasing the force, the friction force will also keep on increasing, but up to a certain limit. It cannot go beyond mu times N. So mu times M that we find, that is only in the cases in which the body is about to move or it is moving. That means the maximum friction force is acting. And in the cases we had discussion before, in all the cases the body was at the verge of movement. That means the maximum force will be acting. Otherwise, lesser value of friction will be there. Okay, you know that, don't you? You have a block kept on ground and it is tied to the wall with a string. From the other end, suppose a force F is being applied and the value of force F is continuously increased. Now, you start from a value 0 and you keep on increasing the value of this external force on the block. What you have to do is you have to plot the graph between the tension in the string and the value of external force very quickly.